This video is about lesson 5-2 about dividing monomials. Please complete the note page that the subteacher will hand you, and then after that note page you'll have some questions assigned that you do on lined paper. Those questions will be given later in this video. Then you staple it together and turn it in at us always. Hopefully I'll be back to school on Friday. Number one, you have probably heard of simplifying a fraction. Some people call this reducing a fraction. So in this lesson, one of the skills we'll look at is simplifying a fraction. Here are several fractions. Let's try some of these. To simplify any fraction, you need to make sure there's no common factor in the numerator and the denominator. So 35 and 42 have a common factor of 7. For instance, 35 is the same thing as 7 times 5. And 42 is the same thing as 7 times 6. And 7 divided by 7 just makes a 1. And so this simplifies to 5 over 6, or 5/6. Now I wrote a bunch of extra work in the video to show you the idea, but what you really want to move towards is being able to do this in your mind, not having to write down the factored forms and then canceling to create the 1. Question B, 16/40ths. What does this reduce to? Well, what is the greatest common factor of the numerator and denominator? What's the largest number that divides into 16 and to 40? Hopefully you realize that number's 8. So 16 divided by 8 leaves 2. And 40 divided by 8 leaves a 5. So 2/5 is the simplified form of 16/40ths. Again, the idea, writing out all of the work steps, is to say that 16 is 8 times 2, to realize that 40 is 8 times 5, and that the 8 over 8 cancels out to just a 1, and you get 2 over 5. Question C, numerator and denominator are both divisible by 5. That number I'm dividing by is called the GCF of the numerator and the denominator. This makes 1/4. Okay, question D, both numerator and denominator are divisible by 10, and this makes 5/3. Your calculator does fractions, and your calculator automatically simplifies fractions. So as long as there's no variables, if you're just working with coefficient numbers, then you can do these all on a calculator. Question 3. Quotients are simplified by factoring the numerator and the denominator and then canceling the common factors. Simplify these quotients. So here's some more examples. These have the numbers in them, but also variables. You focus on the coefficient numbers first and think about what is the GCF of the 2 and the 8. What's the largest thing you can divide them both by? By 2. So I want to divide top and bottom by 2. 2 divided by 2 leaves a 1, and then there's the x and the y. And then in the denominator, 8 divided by 2 leaves a 4 with the x. Okay, I haven't done anything with the variables yet. All I did was focus my complete attention on reducing the coefficient numbers. Again, that can be done on a calculator. Type in the fraction 2/8, push enter, and the calculator will tell you 1/4. Now the variables. Variables are done by canceling common factors in top and bottom. The x divided by the x cancels out, just creating a 1. There is no y in the bottom to cancel out the y in the top. So the final result is 1y, or just y, all over 4. Now question B. Work with the coefficient numbers first, the -3 and the 18. Get that reduced. That makes -1 over 6. Now put your attention to the variables. Anytime there's a match in top and bottom, those variables can cancel out. The a that's in the top and the a that's in the bottom cancel out, creating a 1. There is no variable b to cancel with the letter b in the top. And so the final answer still has b squared in the numerator. You might write this as negative b squared over 6. Now question C. Focus on the coefficients first. There's no coefficient shown in the numerator. Remember, that's a 1. And so we have 1 on top, 2 on the bottom, 1/2. That does not simplify. There's nothing you can do with the coefficients. Now direct your attention to the variables. There are 4 m's multiplied together in the top, like this. There is 1 letter n in the top, and there's 1 letter p in the top. Now down in the bottom, remember there was that 2, but then there's m times m. There's 1 n, but there are 3 p's. What's going to cancel? This m and this m cancel out to a 1. This m and this m cancel out to a 1. There's no m in the bottom to cancel with either of these. Now the letter n, this n and this n cancel out to a 1. Now the letter p, this p and this p cancel out to a 1. There are no more p's in the numerator to cancel with the p's in the denominator. Collecting what remains, there's m to the second power in the top, and in the bottom there's a 2, and then p to the second power. Question D. Let's reduce this fraction. Start with the 18 over 30. You can divide them both by 6 or use the calculator, but you'll get a 3 on top, and in the bottom, the 5. Now the top has an x in it, the bottom has x times y times y times y. What variables will cancel? This x will cancel this x, creating a 1. So what remains is 3 in top, 5 in the bottom, an x in the bottom, and a y to the third power in the bottom. Now, I've done these problems by expanding my exponentials, right? So if it had to the 4th power, I wrote the letter of the alphabet out 4 times just to help show you how the canceling works. It's not necessary to do that if you can think that through in your mind, what's going to cancel and what's going to remain. Number 4 says, see the gray box on page 190. These exponent rules are helpful to divide monomials with exponents. So here is the Chapter 5, Lesson 2 textbook, and scrolling down, we can find the gray box on page 190 that it refers to. Here it looks a little bit like a bluish gray color right in the center of the screen. I see the 3 exponent rules. They involve division. A to the m power divided by a to the n power. And there's 3 different cases shown depending upon if you have a larger exponent in the numerator than the denominator. That's this first choice. Or if you have a larger exponent in the denominator than in the numerator, that's this second choice. Or if the exponents are the same, when the numerator and denominator are completely identical, that's when the answer just cancels to 1. So check, we've looked at the exponent rules. Here they are shown on our notes paper. These rules are used when you have this structure, a division structure involving powers. To avoid having to expand out all of the letters like I had done up above, we can subtract the exponents. Here's our first example. X to the 5th power divided by x to the 2nd power. The base is x, and because this is a division of powers problem, we subtract the exponents. This makes x to the 3rd power. This is the same answer you would get if you took the time to expand. X times x times x times x times x in the top, and in the bottom, x times x. Now, what's going to cancel out and what's going to remain? These cancel out, creating 1. These cancel out, creating 1. The other x's remain, and you have x to the 3rd power left over. Now, our second example, x to the 3rd power divided by x to the 7th power. This time, the exponent in the denominator is larger. When you cancel common factors, you'll have x's remaining. Where are they going to be located? In the denominator. So that's why you see in this rule how the final answer has a 1 in the top, whereas the power remains in the bottom. Let's follow that rule. So we have 1 over, and then x to the 7 take away 3. This answer is going to be 1 over x to the 4th power. This is the same answer you would get if you expanded the variables. X times x times x in the top. Down in the bottom, x times x times x times x times x times x times x. 7 of them. Now, what's going to cancel out and what's going to remain? These cross out, making 1. These cross out, making 1. These cross out, making 1. 1 times 1 times 1 makes a 1 in the top, and the 4 x's are in the bottom. The same answer we got. Third example, x squared divided by x squared. Using our rule, the answer is 1. Does it make sense to you why, if you took the time to expand this out? X times x, x times x. What's going to cancel? What's going to remain? Number 6. Now that we've talked about using the subtracting exponents to help us to divide powers, let's try simplifying this complicated fraction. Start with the coefficient numbers, -2 over 6. They both divide by 2 or use a calculator, but you will get -1 over 3. Okay, now we're going to work with our variables. What happens with the letter C? There's c to the first power in the top, c to the first power in the bottom. The exponents on the c are the same. These will cancel out completely, just leaving a 1. We've already written the 1. Okay, now the letter D. What's going to happen? When you subtract the exponents, where are there extra d's that will remain? Down in the denominator. There's 2 extra d's in the denominator. So in our answer, we will have d to the second power left in the denominator. Now, what happens with the letter E? The exponent of the numerator is larger than in the denominator. When we subtract exponents, 4 subtract 3 makes 1. Where is that e to the first power? Is it in the top or the bottom? And it will be in the top. So the final answer could be written like this: -e over 3d squared. For all of these questions, if this subtracting exponent skill is complicated, then remember you can take the time to expand out the powers and then cross out the common factors using slash marks just to see what remains and where it is in the fraction. Number 7, read about greatest common factor, GCF, of monomials. Then, true or false, the greatest common factor of 2 monomials is their common factor with the greatest coefficient and greatest degree in each variable. In the textbook, we see greatest common factor of 2 monomials, and it says it is the greatest coefficient and the greatest degree of each variable. So the statement is true. Study example 5. Find the greatest common factor of 72 x to the third power y z to the third power and 120 x to the second power z to the fifth power. And the authors have shown out the solution. The first thing they did was put their attention on the coefficients, the 72 and the 120, and found the greatest common factor as we learned about yesterday. Then they put their attention on the variables, and they figured out the greatest common factor of the variable factors. We practice this as well. You find variables that are common to both of the given numbers, and then use the smaller power of that variable. That can be a bit confusing to think about finding the thing called greatest common factor by using the smaller power of the variables, greatest and smaller. It seems a little strange. but we talked about in yesterday's lesson why this is true. Okay, number 8, check. Number 9, true or false. To find the greatest common factor of two monomials, you find the greatest common factor of their coefficients and the greatest common factor of their variable factors. This is true. That is describing the skill. Number 10, explain why the answer in example 5 has 24 as its numerical coefficient. So the coefficients of the given numbers were the 72 and the 120. The authors made the prime factorization of the 72 and the prime factorization of the 120, and then figured out the greatest common factor from those factorizations. Both numbers have the 2 to the third power, which is an 8, and both of the numbers have 3 as a factor. 8 times 3 is 24. We can show that on our notes paper. 72 is 2 times 36. 36 is 2 times 18. 18 is 2 times 9. And 9 is 3 times 3. This is 2 to the third power times 3 to the second power. 2 to the third power is 8. 3 to the second power is 9. 8 times 9 is 72. Now the 120. That's 2 times 60. 60 is 2 times 30. 30 is 2 times 15. And 15 is 3 times 5. So this is 2 to the third power times 3 times 5. 2 to the third power appears in both, and the number 3 appears in both. But we have to use the smaller power of the 3. And so from the 120, we're limited to a single 3. So our greatest common factor is 2 to the third power times 3. This is 24. Please remember yesterday I showed you how you can find the greatest common factor on a TI-84 graphing calculator. Here's our Google Classroom. In the stream, you'll find the calculators. Pick the fourth one, TI-84. To find greatest common factor, click on the Math button. Then use the right arrow to go to the Num menu. Now you want choice 9, greatest common divisor. Type in the two numbers separated by commas, 72, comma, 120. Close the parenthesis and push enter. And it tells us the greatest common factor is 24. Now number 11, explain why the answer in example 5 has x squared y cubed as the variable part of the greatest common factor. The first number has x to the third power, and the second number has x to the second power. The factor x appears in both, and the smaller power of x is x to the second power. The factor y does not appear in both numbers, it's not common. The factor z is in both, and the smaller power on the z is z to the third power. We can write our answer here. Whoop, in writing this out, I notice I've made a mistake on the note page. It wasn't the letter Y that was common to both, it was the letter Z. So please make that correction right here. Now, let's try this skill. Focus on the coefficients first, the 24 and the 36, and get the greatest common factor using any technique you like. Some of you might know that the largest number that divides into both is 12. Now let's work on the variables. The factor A is common to both. What's the smaller power that appears on A? That's just to the first power from our first given number. So A to the first power is part of the GCF. Now the letter B is common to both. Both of them have B to the second power. So B squared is part of the GCF. The factor C is not common to both. So our greatest common factor is 12ab squared. Now question B. Focus on the coefficients first, the 40 and the 24. What's the largest number that divide into both? Well, some of you might know that that's 8. If you don't know that that's 8, then go through the process with prime factorization or use the calculator to get the GCF. Now let's work with the variables. X is common to both. and they both have x squared. So x squared is in the GCF. The letter y is common to both. Now what's the smaller power of y? That would be y to the first power from our second given number. So y to the first power is in the GCF. Now, is the letter z common to both? Yes, it is. How many z's are in the GCF? Z squared. Here is the GCF of the two given numbers. Thank you for completing the notes page. Now you have an assignment to do on lined paper. Here's the lined paper assignment. Please do them like you always do, where you write down the header, write out the question, show work when necessary, and give the answers. And then staple this to your notes and turn it into the sub-teacher. So first we are at page 191 of the Chapter 5 textbook, number 1 from the oral. We're given 3x squared and 9x cubed and asked for the greatest common factor of these two monomials. Start with the coefficients 3 and 9. What's the greatest number that divides 3 and into 9? That is 3. Now the variables. X is common to both, and the smaller power is the x to the second power. Number 3, we're given 15a to the fourth and 21a squared, and we're asked for the greatest common factor of the two monomials. Start with the coefficients, 15 and 21. The largest number that divides both is 3. Now, the variables. There is an a in both places. What's the smaller power on the a's? The a to the second power. Number 5, find the greatest common factor of these monomials. There are no numerical coefficients, only variables. The variable p is common to both. The smaller power is p to the second power. The variable q is common to both, and the smaller power is q to the second power. Verse 7, given these two monomials, what is the greatest common factor? Looking at the 7 and 14, the largest factor that is common to both is 7. Now the variables. There is an x in both places. The smaller power is the x to the first power. There is a y in both. The smaller power on the y is y to the second power. Now to the written. Number 1, 42 over 63. The directions are to simplify the fraction. This can be done mentally. This can be done on the calculator. Just type the fraction in and push enter. This can be done by factoring the top and the bottom and then canceling out common factors. However you want to get the answer. 42 and 63 are both divisible by 7. 42 divided by 7 makes 6, and 63 divided by 7 makes 9. 6 over 9 is further reducible. 6 and 9 don't both divide by 3. Creating the answer 2/3. The fraction 42 out of 63 is the same thing as the fraction 2/3. 10 to the fourth power divided by 10 to the sixth power. This can be done with a calculator. Just type in the fraction, push enter. This can be done mentally. This can be done by expanding out the tens, 4 of them in the top, 6 of them in the bottom, canceling out the common ones to see what remains and where it's left over. This can be done with the rule that we were learning about today, about subtracting the exponents. I'm going to apply the rule. There are more tens in the bottom, so when I get done canceling, I'm going to have any excess tens in the bottom. 6 take away 4 makes 2. The answer is 1 over 10 squared. If you want to, you can say 1 over 100. Number 5, 12a divided by 3a. Do your coefficients first. 12 divided by 3, that makes 4. Now what's going to happen with the a's, since there's the same amount of a's in the top and in the bottom? They're going to cancel out to just a 1. The answer is 4. Verse 7, 6 times 10 to the fifth power divided by 3 times 10 to the third power. You'll learn in your science classes that these numbers are in a form called scientific notation. So you're going to use this when you're a sophomore and junior a lot in science. You can type this in the calculator and push enter, or you can work it out mentally. 6 divided by 3 makes a 2. Now what's going to happen with the tens? I'm going to apply the rule about subtracting the exponents. 5 subtract 3 makes a 2. The answer is 2 times 10 to the second power. This is 2 times 100, which is 200. Number 9, 4x to the 5th power divided by 8x. 4 over 8, what happens? 4 and 8 are both divisible by 4. So if you divide the top by 4 and the bottom by 4, you will get 1x to the 5th divided by 2x. Now, what's going to happen with the variables? The x that's in the bottom will cancel away 1 out of the 5 of those, leaving 4 of them left over. The final answer is x to the 4th power divided by 2. This is the same answer you would get if you subtracted the exponents. 5 subtract 1 makes x to the 4th power. This is the same answer that you would get if you expanded and then used slash marks to cancel out the common x. Number 11, 12 divided by 4 makes 3. There's an x in the bottom with no x's in the top to cancel with it. Now what's going to happen with the y's? There's 1 y in the bottom and 3 of them in the top. Subtracting the exponents, we get y to the 2nd power in the top. Number 13, negative 9x squared y cubed divided by 12x y squared. Start with your coefficients. What's the GCF of 9 and 12? What's the largest thing you can think of to divide them by? That would be a 3. This is going to make a negative 3 over a 4. Now let's think about the variables. We have x to the 2nd power in top, x to the 1st power in the bottom. When you subtract exponents, you get x to the 1st power, and it remains in the top. Now what about the letter y? What do you notice about the y? There's 1 more y in the top than in the bottom. Here's the answer. Next is number 31. We are asked to find the missing factor. What factor needs to be written in the parentheses to make this a true equation? How do you make the right side equal to the left side? What's missing on the right side that needs to be there for it to be equal to what's on the left side? Well, if this is a 6, on the right side we need to have a 6. We've already got 2 so far. 2 times what makes 6? We need a coefficient of 3. That'll get us the 6. Now let's look at the t to the 4th power. How can we have t to the 4th power on the right side? We already have 1 t. How many are we missing? We need t to the 3rd power. Our missing factor is 3t to the 3rd power. If you multiply together 2t times 3t to the 3rd power, that's the 6t to the 4th power. Next, number 33. What's the missing factor? 3 times what makes 9? We need a 3 here. Now the letter a. How do we get a to the 3rd power if we already have a to the 2nd power? How many more a's are needed on the right side? 1 more a. Now look at the letter b. How do we get b to the 4th power? We already have b to the 2nd. How many more are needed? B to the 2nd. Number 35. What's the missing factor this time? So 7 times what makes negative 35? We need a negative 5. And what about the letter x? If we have 1 more x here, then x to the 2 times that 1 more x is x to the 3. And what about the letter y? We need y to the 4th power. And finally, number 37. What's our missing factor? Work with the coefficient first. We want to have 48. We got the negative 3. We need to get that coefficient. Negative 3 times negative 16 is 48. Now we need 2 more c's because 3 of them here, 2 of them here, makes 5 of them. And we need d to the 2nd power because 2 of them here, 2 of them here, makes the 4. This concludes the video about Chapter 5, Lesson 2. Please don't forget to staple your notes and your homework together and turn it in to the sub-teacher.